you know, what people consider cursing.
We're going to the county building past Southpointe. It's across from the big lake.
I mean, you know, like the X Factor, I think it is when you have
it's the cow building.
Every exit get it out, you know.
Come in that
okay, well, I'll get my 3 minutes, you know, and try to do this thing. And hey, Scott, Tom, and also, I have to tell you right here, I'm considering this my dissertations in masters, in my masters in presentation, because I have not rehearsed it out loud once.
Well, you know,
it is cold.
Don't encourage them to practice too much, right? That's the way to do it. Okay, so the video is live now. You know,
terrific.
So we're streaming on YouTube.
Am I?
Yeah, it's in all the other rooms too.
Wait, and sound, right?
Yep.
And sound, right? Yeah, I love it. And this out. Hello. Bueno. Yep, you're on the world right now.
So they have that.
I mean, I'm gonna write it in once now that I'm not gonna say it out loud, but
I'm just gonna practice.
Right.
No.
Right. Real close to being able to put some stuff.
Well, frankly, the reason I'm back is because I accept everybody because I was so impressed from the all class presentations. And those were really off the wall thinking. They would do probably stuff that the industry is working with already, but they were able to latch on that and explain it. It was really clear.
The thing that's neat about this one is his wife gave him. They sell these, for lack of a thing, kind of radiator cells. So they pipe with water.
Yeah.
They're beds and flats. So she asked them, give me an algorithm. So if I know I have this many elbows and this many straight pipes, how would I increase it? So instead of trying to work, they said, well, she's going to test 35. They're on literally on this line.
Yeah, on the spot testing.
So
This is wrapping up at 1 o'clock. I have to make something at 1:30, so I have to leave here
you
at
can leave,
1:30.
yeah, whatever you.
Okay. But there's essential things that are missing.
It'll also be on YouTube.
Okay.
I'm streaming this live.
I am streaming.
You are streaming this live? Yes.
Yeah.
It's on right now in the other room.
Remember, Brian, this is all your idea.
I didn't do anything. Oh, I'm up front.
You're in charge of him.
I
You
know.
know, this young man.
No, how you doing?
Darby Cooper.
Pedro Quiroga.
He's the director up at Parkway.
Oh, okay. Nice to meet you.
So he's always looking for good welders.
Yep.
We have a lot of.
Yeah, in Parkway West.
Yep.
Yeah, I am part of your advisory board for the building program.
Okay, wonderful.
Yeah, been doing that, and we'll here to support. You know, yeah, he's one of our leading engineers, and he's a PTI graduate. And,
I actually went through the Beaver competency.
Okay, cool. What year did you graduate?
2009.
Okay, so Mrs. Capital was the director, and
I was working in the graphic design
Okay.
with Martin Jack.
Yep, absolutely, sure.
He's from the Almanac. I'll just share some preliminary thinking, some stuff we're going to share with you
Sooner, yep, absolutely. You said Barry and Mike are coming?
Yes. Did you bring the paper too? Sheets and the packets?
Well, I have money? No.
The cash?
Cards?
The cash, half of it.
Yes.
I can be mobile.
You know,
I can be mobile.
I got there about $6 when I was nonstop.
Bueno,
I'm leaving here to go to Edgewood for the prostate protection. Nothing, so I mean, it's just
Good stuff.
nonstop, and I'm out there.
I know.
I'm in the other room.
Hello. Bueno,
Actually, I don't have to pick them.
kids.
Yeah. Oh, there.
The kids are supposed to be watching. Oh, so I can't be more with this thing. That is good.
You're probably streaming everywhere live,
That's great.
like the internet.
Let me just take this time right now to
Hey,
tell.
Yeah.
No, still not personal.
yeah, there's all foods, now fruit, right in the next room.
Oh, okay.
All right. Well, it is what it is. I am not going to rehearse. I'm going to go out. Let's do it. You know, I have 30 seconds. No, 3 minutes. And I just need to remember. I need to switch at 35, 111, and 2. No, and 150. That is the timing that I have for.
You doing slides as well?
No. Just one video. I made my presentation, but I made my whole presentation in one video because they made a bet.
So your timing.
These people made a bet. Can you believe this? They made a bet that I cannot present and that I am not able to just talk for 3 minutes only.
Yeah.
And that I am not able to have those 3 minutes without cursing or without being politically incorrect. And I'm like, I have to have 3 minutes, you know what I mean, of actual talk. Then I need to finish with a bang and have a little introduction. You know what I mean? I'm taking 14 extra seconds.
14 seconds just covers the very part.
Yeah, the laughing, you know, the laughing part. But no, right now my biggest thing is that I told them, okay, so what I'm gonna do is I'm gonna go ahead and think it in a way in which there's no way that I can stall. You know, I mean, I'm like a Houdini, you know, that you go ahead and you grab yourself and you put shackles and all the different stuff, and you put yourself upside down into the water, and everybody can see that you're going to the water, and I was ready to come out like this or die. You know,
So, but you had to rehearse along with this video, of course, the time of now.
I mean, I did my mental, but I have never say it out loud. Never seen saying out loud against a mirror or anything like that. I never do. I always, when I speak, I normally speak. So, like, yeah, I just have an idea. And I never watched my presentation. The only thing is in this one, I actually have here, I have to watch because it is a timing. I mean, I have a little message. I decided that I'm going to use my time to promote the class. I'm going to use my time. I mean, not every day you have legislators. Not all the day, every day you have to turn to high school officials. You know, every day you have to have a group of Sorry?
Started here, the program?
I believe so. Yes, sir. You can start over there if you are hungry, or over here if you're ready to learn. I guess. Hi, I'm Pedro Quiroga. Pleasure to meet you.
I'm Jim Blue. I work for Brandon Newman. He's the state rep in this
Oh,
area.
perfect.
He couldn't be here today.
I'm Pedro Quiroga. I'm the main peon at
Likewise with Brandon Newman.
That's right.
Where are you guys located?
We have a shop over here in Oakville, North Carolina. This is my wife, Claudia.
Jim Blue.
She's the president of our company. And she is the
What do you guys manufacture?
we do the electrical furnaces to mix it. My wife and I started many months ago in a big OEM, you know, used to be called Flip Systems, that became called Southpointe, which actually is the thing that works here in Pittsburgh. We're here. We actually used to come to work, not only drive, just off the hill. And then we were here until Siemens took over. And then when Siemens took over, my wife and I said, you're on. And we started to do our thing, our way. And since then, that was in 2006. And then, you're doing well now. Good. We're still here. Yeah. We're still kicking. A bunch more gray hairs. I did not have a single one when I came. Look at that. It that it just still snow. So it's a good thing.
It's the first time I've been in this building. It's very nice.
Yeah. Oh, well, I'm going to go and grab a glass of water. I'll be back in just a minute. Yeah.
Singer, yeah, that's Blue, yeah. It's been a while. How's it going? It's going well. I'm doing well. How about you? Good. Yeah, you with Norman? Oh, observer now. There's a JPA radio guy here though. Yeah, I saw him. So how's it going? It's going well. You were also. Yeah, I was in the master program.
Where do they want us to say that?
Why don't you guys take these two seats here? Because what we told the kids is that this is, you represent North, you know what I mean? This is about representing the other. So I want you guys to-
Okay, I'm gonna close my stuff.
Well, it's not written, right? I got more out of working while I was undergrad.
They're gonna watch from the other room. So we're gonna
Oh.
bring everybody in, but only the kids who are presenting will be in.
Because that's the electronic and that's it. Okay.
But that's why we stream, so they can watch as if they can get feedback, they can do all those things, but they don't have to do it.
That's it. That's awesome.
How many folks?
So is Mark, you
Hey,
know,
Mark, how are you? Come over.
Unfortunately, I'm
And you know,
really upset. Getting the press release
Okay. Why don't you guys take the board here?
Yeah, I talked to Brad a lot.
Oh, yeah.
This is what we told the kids, their job, they're presenting to you guys today, everybody else is business.
Mike and,
So, you know what I mean, they need to.
Rick too.
And then Paul and Bobby are coming, but they're until.
We're good at networking too, and they really have a feel for what should be covered, what shouldn't, and what they're at. Well, they're very experienced.
It's interesting, last time we made it at the.
Nice work.
So we, everybody.
What else you got on your
Was
schedule?
not allowed to be heard, the kids are-
Well, there's letter speaking writing, we're in the middle of that, pretty much me and this guy here. I need to get a Friday deadline for that. So that's hot right now. Somebody wants to meet.
Yeah, they told you so.
Somebody-
Are you acting as
Think
a
about
boss
it.
ambassador?
Yeah, it's one of the, it's one of the, it's what
Not later
happened.
than tomorrow. Tomorrow.
He just wants to get
Courthouse.
2 seconds ago and take your phone and to.
Yeah, it was, I also involved the United Way.
Yes.
Do you have the, nice people there to work
Paul,
very
here at-
professional. Very careful how they manage the money. They're
Buzzies, yeah.
learned a lot of work.
Paul, here at.
I'm only loosely familiar with them because the Observer does.
Your presentation is
They're very well connected to the integration with
Your 10.
involved, might be more involved in the future.
Yeah,
They're all
they're
welcome.
10:20. They're gonna come to watch, the 5K and then the one after lunch. The 5,
They're digital display. Yeah, so that'll be the one right before lunch, right after.
yeah, and, our customers. Just like they will be able to. So, yes, we'll be there.
The real world solutions to the team.
Please come in.
Cost-effective way to prevent oxidation.
Hopefully they're not watching that.
I will be watching this.
I mean, I can't. Yeah, you
It's not too bad.
It's the presentation.
That's why I'm going to be here, so you have it. You guys have to all do
Strong support.
Oh, I don't think so. And you're gonna bring a pipe.
Let's get these companies.
Right.
That's a big way right here.
Right.
Maybe we can party there. There's done a lot. Let's go to this. Center of innovation.
You can stop. Really. Yeah, it's not like better. We had this conversation. I haven't seen this conversation.
Yeah, I started talking about the jobs that I did.
No.
Okay. Just has the train I know on that you guys got it. That did have to show a couple of clips of like Oregon State over there.
Selfies.
I expect a lot of this. That's all.
Get some feedback.
No, man, watch one.
That's all right, because you gotta pick up some, Scott's got some stuff.
Yeah, he forgot
That much stuff.
I don't think so. Ask him for you, what happened.
I'm gonna sit on the other side of you.
The other things, there are 2 things, folder, all the handouts, and if you wanted to give some assessment information back to the students.
You guys it'll be on code, yeah, so that way, you can see what they're saying without having go right up the other right, against that wall.
Anybody else need a handout? The evaluation report. Move around just a little bit more. That should fit.
I think that one actually. That one and that one.
Yeah. I
Me?
First grader.
Good morning, everybody. It is so great to see so many highly scrubbed and well-dressed young people here. This is such an incredible program, an incredible opportunity for so many of our young, brilliant minds in the making. And I know it's going to be something incredibly beneficial to our area right here. You're sitting right in the heart and soul of the Marcellus gas and oil industry. And as a matter of fact, I'm the state senator. I didn't even introduce myself. Sorry about that. Camera brought a lot of state senator. I'm also on the vice chair of the Energy Committee for Pennsylvania. So that's why I decided to plant myself right here in this building. Actually, my office is on the second floor. And anytime any one of you guys want to come visit me, the door is always open. But we really need to encourage thinking. Too many times, and actually what's happened the last couple of generations with our public school system, we're teaching our kids how to memorize. We're not teaching our kids how to think, how to problem solve, critical thinking, working as a team, finding your strengths and improving them, and actually recognizing your weaknesses and acknowledging that and improving on that. So I am really, really excited about this whole program. I think it's wonderful. I'm so glad to see so many kids involved, and I hope it just grows and grows. I'm very excited about the possibility, and we're hoping to maybe create an incubator here, even in this very building, to continue the success and the model just like this one. I congratulate all of you for your hard work. I'm very impressed, and I hope you continue, and I hope you encourage others to participate as well. Thanks so much for bringing us here. Thank you.
Hi, good morning. My name is Tom Isaac. I'm one of the teachers here from South Fayette. I just wanted to make a couple of quick thanks. First of all, thank you primarily to Pedro and Claudia. We can't thank you enough for opening up your company and your problems to us to be able to take a crack at being able to solve. So thank you very much for everything you've done. And yeah, All Clad is here as well. Thank you guys for coming out. That was our last project. Also, thank you really to the administrators and all of those people who have given us enough rope to be able to hang ourselves. Hopefully we'll prove that today. Really can't thank these administrators who have gone out on a limb to really be able to give us the opportunity to give these students the chance to be able to do what they do. I think you'll be impressed by what they're able to do. A lot of other people here, I would like to make a brief thanks, and that's to all of the people who have helped us, from Luma, from Mr. Rida, from All Clad, For all of the other people who have helped us through this process, thank you very much for all of your hard work. I'd like to introduce Mr. Pedro Quiroga for being able to open up his company to us, and he's got a few things to say to you as well. They
told me I can be mobile with this, right? Anyway, I need somebody to get the play button. Time out before we start that. I'm gonna steal 5 seconds of this thing. Apparently there is a bet around here that I am not. He asked me to only speak for about 3 minutes, and there are bets, that have been placed that I cannot, speak for only 3 minutes without cursing. So, as a man of challenge, I want to tell everybody that I am going to take it by the force, like every single one. And I am doing right now my dissertation in what I call my master's in presentations, as I have never rehearsed this thing out loud. So let's see how this goes. There you go. Anyway, they asked me to, like I said, my name is Pedro Quiroga. This is my beautiful wife, Claudia. We started our company in 2006 after 10 years. I'm supposed to go for 3 minutes without cursing, so I'm going to try it. So we are located right now very quickly here in Oakdale, okay, Pennsylvania. We started our company actually in McDonald, PA, and then we moved it to a bigger building, right there, that one that is showing up. And basically what we are is we are steel manufacturers. We do heavy welding, we do electrical furnaces to make steel, the ones that the steel mills go and do, all that nice stuff, okay? And I think I haven't cursed yet, if somebody has a bell, rang it whenever I curse, supposedly. Anyway, allegedly. But I want to take my time to actually send 3 messages. First of all, to the government authorities. For you guys, thank you. Thank you for setting up the place, for setting up the platforms, to be able to have this kind of program. Starting with the people from the school boards, to the people in the state senate, recognizing this need is amazing. And for that, me, my wife, and everybody at EFI, we thank you very much for it, okay? I also want to take the moment to speak to the school officials, okay? From the directors to the principals, to the teachers, The thing that you guys do over here, Scotty, Lou, Freddie, Tom, Brian, there you go, that's over there. My respect to you guys. What you guys can do over here is amazing, okay? Trying to guide these kids through this, through this process. It is important. It is important to us as an employer, okay, to have the incredible advantage to take a peek of what's coming up in about 4 or 5 years. That is something that I was saying to somebody outside. Sometimes you actually pay consultants to tell you what we're trying to get over here. But most importantly, I want to speak to the students. To every single one of you guys that went to our shop, thank you. It's been a privilege for us, okay, to work with you. It is important that you guys know that you guys are going to go and study a bunch of different stuff and a bunch of different things. Try hard. Find the things that you guys like, okay? Find passion on it. Every single time that you have the chance to learn, okay? Because I'm going to tell you one thing. Sometimes you guys are going to choose something. You're going to go to college, study what you like the most, that nobody knows more than you, and learn how to have fun with that. That is the only way to become successful at what you do, okay? If life doesn't give you the opportunity to do that, learn how to do, or how to have fun in what life throws at you. Even if that is not what you chose in the first place. That is the key. Learning how to learn. That is what you're doing over here. And we thank you very, very much. And Tom, I believe this is what I call a 30-minute presentation. Thank you. And that's the band.
Thank you very much.
There you go. I just want to know how much Claudia paid you.
All right. Well, thank you very much, students. You can all file out. You can watch on the screens. We're going to start right out with the looked at labor costs. All right.
All right, hello. I think we're going to start with our names. I am Jack Shea. I'm Mihir Gita.
I'm Carolyn Davies. I'm Kara Price. And I'm Eliza Browski.
All right, and we are labor cost calculations. So, pricing is a very integral part of any corporation, especially if considering that they make a very low quantity of very highly valuable products. So, and to determine what they're going to price on, they need to know the costs that are going to go into it, specifically the labor costs in hours that's going to go into it. So they need to know how long it will take to build their product before they even build it. And that was our task. We need to develop a formula where the inputs would be characteristics of the products that they're going to make that they can determine prior to making. And then the output would be a projected number of hours that the project will actually take to build. To accomplish this, we split the projects up into two main categories of families as the roof panels, which are the panels that surround the outer shell of the arc reactor furnace, and the roof panels, which go on top. And not only do we want to develop an equation, but we wanted to deliver it in a very easy and streamlined fashion that EA Fab could use in a very easy way.
So just some background information. Initially, we were not given the current system that EA Fab uses so that we wouldn't be forced into a certain way of thinking. We later learned that the system is based on returns. Returns are U-shaped pipes that go, and you can see them in the diagram on the edge of the panels. This is a very simple system, and ours is much different than that. We were also given a plethora of information through an Excel document and technical drawings. The Excel document had a catalog of all the jobs that EA Fab has worked on. These jobs were divided into different tasks, such as layout, material preparation, painting, and manufacturing. These hours were divided by people, by the workers that worked on them, and they were an important part in how we got to our function. We were also given technical drawings. These drawings had all the physical information that we needed, such as the number of pipes and returns and like physical information like the length and width of the panels.
To begin looking for our solution, we use Lua methods, which are methods of engineering that help you to better define the problem at hand, and they also help you to narrow down your solutions to the ones that work the best. The first method we used was a concept map, and it helped us to display the relation between the formula we are creating and how the panels are constructed at EA Fab and everything that goes into making a panel. The next method we used was abstraction laddering, which helped us to better define our problem and figure out what we were trying to solve for and how we're going to do it.
I'll speak a little bit about our approach to the problem. So what we first got on the first day that we visited EA Fab was a spreadsheet with over 14,000 rows in it. So it was a little daunting at first, and we got some design files. So first we had to organize our data and documentation. And we created a new spreadsheet and we organized it into the roof panels and the sidewall panel information. And then we had to look at our variables that we thought would impact our formula. So we looked at number of pipes, number of turns, number of elbows, etc. And we had to organize this all into new spreadsheets. And we did have two different approaches. We had to create two different formulas because there are two main families, which was the roof panels and the sidewall panels. So we had South Fayette, we kind of focused more on the roof panel formula, and then at Upper St. Clair, they kind of focused more on the sidewall panel formula. So for the roof panel formula, we focused on the data that was given to us, and we really used correlation coefficients and linear regression to create our formula. And for the sidewall panels at Upper St. Clair, they focused on feedback. So they interviewed, they observed, and they looked at the estimated times for each process. And then they refined the formula through regression, which we'll talk about a little bit more later. As you can see in the picture, this is a standard EA Fab roof panel. So first we had to organize our data. We had to identify the relevant jobs that we thought would really impact our formula, and so we relied on the available documentation, and we eliminated extraneous tasks. For example, they gave us number of shipping hours, but we didn't need that for our formula. And we also had relatively few data points that were applicable compared to the sidewall panels. So we extracted these variables from the design files, and we had to look at materials lists, CAD drawings, specifications, and we had to really put all this into a new spreadsheet that would organize all our applicable information. And this was very time consuming because EAFAB is a relatively new company, and so the documentation does vary over EAFAB's history. Next, we had to identify the trends. So we looked at the correlation between hours and the variables, such as number of returns, number of pipes, number of elbows. And the ones that we really focused on, which had the strongest correlation, was the number of pipes, number of elbows, length, and the dry weight. And when we talked to our clients, they said that we should eliminate the outdated jobs, so the ones that were more towards the beginning, and the irregular designs. And plate hole numbers were, even though it had a pretty strong correlation, we didn't use that because the numbers were initially unavailable. And our methods to count the pipes differed a little bit, so we eliminated that even though it had a strong correlation.
After identifying the basic trends in the variables, we performed linear regression with input or x values of elbows, length, and weight, and output or y values of the hours it took in the records to complete a job. This allowed us to generate the slope and intercepts for the line of best fit, which gave us a rudimentary way to estimate the number of hours. Of course, each of these equations was initially based on one variable, so we had to, we had to refine them further by testing the initial equations. We took a variety of approaches to this. One was taking the average of several linear regression estimates. So if one drastically overestimated the number of jobs, another might bring it down. We also weighted these averages based on the strength of a correlation coefficient. For example, if it was 0.9, it would have a higher weight in our formula than one that only had a correlation coefficient of 0.85. This was meant to give preference to the variables with the strongest correlations. However, we found that it actually didn't increase the accuracy of our estimates by that much because the correlation coefficients were all so high and so close together. This would have helped us more if we had correlation coefficients of, say, 0.6 and 0.9. We also tried combining different variables. Although we focused on weight, elbows, and length so far, we did, as Carolyn explained, analyze a variety of data points. However, we ultimately did decide to focus on weight, elbows, and length as compared to all of them put together, both for the sake of simplicity in the formula and also accuracy. Our final formula was hours equals 0.00915 times the estimated weight of the panel plus 1.075 times the number of elbows plus 0.294 times the length, and that's the entire length from one end of the panel to another at the bottom, plus the constant 96.14. You can see below a chart comparing our estimates to the actual values, which I will go more into depth with the error analysis. Our average error was 0 hours. However, that's not quite as good as it sounds. Our absolute error was 14.59 hours, which is still pretty good. That's a percent error of 9.96%. We believe that this is quite accurate, but potential sources of the error are that EAFAB is a dynamic workplace because their panels are made by humans and not machines. There's expected to be some variables between, for example, if 2 different employees are working on jobs. There could also be manufacturing errors in the initial documentation. These are indicated as early work, however, smaller setbacks aren't necessarily reported. We further believe that this is an accurate estimate because reported labor times for identical jobs can vary up to 20 hours. Now Jack will be talking about these sidewall panels.
All right, sidewall panel formula. So our basis of our sidewall panel formula was a little bit different than the roof panel formula, primarily because of the very different ways that the actual panels themselves are manufactured. And we found that the pure data way of this roof panels wasn't as suitable because correlation wasn't generally as high. So we took a different approach by adding up the time per process that the panel goes through by splitting up each panel into a number of processes and then multiplying by the amount of time it might take to do 1 unit of that variable. For example, if we were splitting one of our processing up into welds, then it would be 1 weld times however many times that the job is performed by the time. And then we use linear regression for variables that we didn't have definitive times for. So our first step completing this was identifying the processes and the determinant variables that were going to be in our equation. The first one we looked at was pipe processing. This includes the cutting, the beveling, and the rolling of the pipes that are used to make the panels. And we determined that the variable we were going to use for this was number of pipes because, in theory, the number of pipes should vary directly with the amount of time it takes to process them. Layout was a little different in that it was a bit more complicated because we didn't have specific time estimates on layout. So instead, we used a regression technique, which I'll go into in a bit, varying on surface area or weight. Return and elbow welding was another one looked at, which we determined would vary directly based on the number of returns and number of elbows, time a constant of how long it would take to do one of those welds. Air and water testing was something we held constant because the difference in the amount of time it would take to air and water test would be negligible depending on the size of the panel. Plate welding was, we decided would vary on both the perimeter of the panel and the number of plate holes. In the end, we actually averaged out our time estimates for the number of plate holes because it would not work to use them in the actual equation because they're not always readily available on project sketches. The letter welding is the act of just literally welding the letters of the fab onto the panel, which we held constant because it wouldn't vary with the actual size of the panel. Painting was going to directly correlate with surface area, which we use through the regression technique, similar to layout. Extraneous tasks, how we compensated for them, is that after we determined a primary formula using the first processes, we added on our average error and accounted that for the extraneous tasks that it would be impossible to account for, and it overall made our equation much more accurate. So how we use regression analysis in the sidewall panels is we first did it with layout, and what we did is instead of regressing specific variables to the entire time of the panel, we regressed specific variables to the time it took to actually lay out the panel. And we used that varying against surface area and weight and found that weight had a much higher correlation, which caused us to use it as the determinant variable for that subject. Painting, we did a similar idea, except we regressed it against surface area because painting would directly correlate to how much surface area there is, because the more surface area, the more time painting. And we had relatively strong correlations for that, which caused us to use that as a determinant variable. So this is our final equation for the sidewall panels. How it works is the first 1/60, that's basically dividing our entire formula by 60, is because the formula itself is in minutes, and to turn that into an hour estimate, just dividing by 60, and it just makes the formula look a little cleaner without a lot of decimals. The 24p has to do with the number of pipes, adding up the net number of time it would take multiplied by the number of pipes. The 24 is a coefficient of the time it would take for a single pipe. The 30R and 20E are the coefficients of return and elbow welding time, which would increase with the number of returns and number of elbows because they would have to weld more. The 0.204 weight was for the layout, which is how we regressed it. That was the slope of the line that we used to regress for layout against the weight. And so that was the coefficient of weight that would factor into the amount of time it would take to actually lay out the panel. The 0.0018 length times height has to do with the painting correlation. That was the slope of that painting line that we discovered with surface area and how it varied against that, similar to layout. And the 1.06 length times height has to do with the perimeter welding of the panel. And that's the correlation that we determined through a proportion that we set up for that. And the constant has to do with everything else we didn't account for, such as the testing, the letter welding, the plate welding, the average plate welding, and our extraneous error.
So I've been told that we're running a long time, so the pressure's on. This is a portion of our Excel document used to gauge the effectiveness of our function. Everything to the left is all data taken from the technical drawings, and the column all the way to the right is the predicted number of hours from our function. The column in the middle is the actual hours spent on the job. In your packet, there's the full portion of that Excel document. You'll notice that some of the predicted hours are green, white, or red. The green boxes are instances where we considered that our function performed as it was expected to. The white is where it was unsatisfactory, and the red are cases which we consider outliers due to errors such as, well, the data that we looked at through the drawings would suggest a lower time spent on the job, but the hours spent were more, which we consider just human error. The percent error on the Excel document in the handout is different from the one on the board, and technically that is correct. But we later realized that the more accurate way of representing the data would be to calculate it a little differently. That percent error is calculated from the average of the hours, of the actual hours and the calculated hours. And this percentage error is calculated on each individual task, the average of all the tasks combined.
So for our final product, we decided that it would be best to create a web app to present our results. So we decided to choose a web app because it is accessible from virtually anywhere on any device, and it's very simple to use. It can be supported on any phone, Android, iPhone, anything, tablets like iPads, or desktop computers, Mac or PC. Since technology is such a big part of today's society, it's important that our app and formula can be accessible from anywhere very easily. To design our app, we use the Loom method of schematic diagramming to plot out each different screen of the app. So I don't know how well you can see it, but this is the home screen of the app. And what you do is first you select which specific panel you want to calculate the amount of hours for. In this case, I selected the sidewall panel. And then you enter in all of your variables, like the number of hikes, the number of returns, number of elbows, the weight, the length, and the height. Then you press the calculate button, and it brings you to this screen that gives you an estimate of the total time that it takes to build the panel. So once you get your result, you can either print your results, which when you click on the print button, it brings you to a summary of all the variables that you typed in, and then your estimate of total time. Or if you want to retry the calculation for that panel, you can retry it, or you can go back to the home screen. Does anyone have any questions? Also, we have the website up if the crew has have. Okay.
It's actually live and running. So it's actually learning.
So if you wanted to test one of the
You want to test it right now? Me? You guys want to go now?
Well, we'll go ahead lunch.
okay.
I think Mr. Goldhart, but
Yes.
Yeah, did you learn about linear regression in a class that you're taking, or is that something that you became familiar with just for this this particular project?
Yeah, linear regression was something that I'm sure we all learned in class, but I don't think we ever thought that we would apply it in this kind of situation. But yeah, it actually worked really, really well for like determining the slopes for the coefficients in our equation.
What would you say to educators about this way of learning versus strictly classroom teaching?
I think project-based learning is, this class was one of my new favorite classes in high school. Project learning is just a completely new way to approach high school education. Like I was saying before, it's not memorization. There's no real, as in lecture kind of learnings that we go through. We basically come in, we're given methods that we can use to approach these problems, and it's basically creativity at its finest.
You basically take everything that you've ever learned, and apply it.
So the app that you created to to utilize all this information that you put together, can you tell me what the process was? Was that a 5-person effort? Did everybody put into that? Was there one leader? I think it's an incredibly creative approach to
making this a usable tool?
So my brother is a freshman in high school, and he's very talented at creating apps. So basically, me and him just sat down for like 2 hours, 3 hours, and just like, I told him what I wanted to look like. I used the schematic diagramming that we made, and he typed in the code and the programming and whatever, and then it came out as an app, basically.
Yeah. Any other questions?
Well, outsourcing.
I don't have a question, but I think what you guys did is great. I told you that I wanted different ideas, and you guys came up with 2 different ideas.
Great.
So definitely, I have tried it, and I understand when you guys all the problems that you have because different people take different time and all the way work. So it was a challenging task. I really understand that, and I think you guys did a great job. Thank you.
All right, thank you very much. We're going to move on to the next presentation now.
Good morning, everyone. My name is Megan Banerjee.
I'm Vicky Lang.
I'm Riley Kohler. And I'm Sam Cohen.
And our task was to complete a submittal form for EAFAB. So many of you probably know that sorting through files takes a long time, whether done manually or electronically. So this almost inventory is taken in this submittal form. So what is the submittal form? Basically, EAFAB provides its customers with this form that has the file types and file names of each of the files used in the project, whether it be documents, spreadsheets, or inventor files. Anything that's used in the project is given in the submittal form, which is then given to the customer. So our task was to create sort of a submittal form that would be more efficient and more effective. This is the file transmittal form that was provided for us that EAFAB was using originally. And basically, our problem definition was to create a more efficient way of making the submittal form, because obviously this takes a lot of time to do manually. If we go through each file, it takes hours a day to go through that and put it into this form. So our task was to create some sort of program or some way to make this process a lot faster and more effective, since we don't want to waste time and we all don't have enough hours in the day to complete all our tasks. So that was basically our problem definition.
So the plan was initially form a Luma method plan, and Luma is just like it's methods to go through problem solving to help your process. And develop the best ways of executing the program. For example, like what kind of programming language, what the interface will look like, etc. Actually creating the program, being able to remove any bugs or anything that happens and have it functioning, test and troubleshoot the program so we can make improvements upon the first prototype, and then evaluate our final solution to see if it does what our client actually asks it to. So the Luma method stuff that we chose was interviewing, schematic diagramming, concept mapping, and abstract laddering. Abstract laddering is a way of taking the original problem statement given to you by the company and then determining the hows and whys to go in a more general and a more specific direction to determine if that problem statement is of the highest priority that you should be solving. Our team was able to determine that the problem statement we were given is indeed the one we're trying to solve, but all the hows and whys that were generated were still useful in letting us know like how to keep on track with where we're going as we go through our process. Concept mapping is taking all of the objects, processes, and people involved in the domain of our problem and seeing how they're related to each other. And this was, again, another thing that was helpful to keep in mind as we go through our process and then eventually implement the final solution. Schematic diagram is kind of a chronological flowchart of the final solution. It was especially applicable to our group because we ended up with a program as a final solution. It was useful because we could go through and see if there were steps that we could combine and simplify to make for a better result overall. The schematic diagram you see here is the result of like 2 or 3 other prior schematic diagrams that we eventually improved upon. This is the first major step. You just open the program, then you choose the folder that contains the project. It'll run through the program, open up Excel, and then you can go through, approve all of the information that the program has gleaned, and then enter the header information for final submission.
Yeah, and throughout this whole process, we had a lot of questions for EAFAB, so we interviewed them, and we asked them, what are the files like? How many files are there? How are they organized? How are the files sent? And what operating system should our program run? And it just helped us to determine how we should go about solving our problem. So this helped us to clarify what our problem, what really was. And it was to make a list of all the files in the project, include every file's name and type, and not really worry about organizing the project files as much, but just generate a form. And if possible, we were told that we should add data from the inventor properties of the files, of the parts and drawings and stuff, to make sure that the customer knows what this file specifically is. When it came down to programming, we used a programming language called VBScript. We chose this because it's included on all Windows computers by default, and we didn't want them to have to install anything, so it can just be run straight off the bat on a Windows computer. However, it requires Excel to be installed. And during the programming process, we used many applications to help us. These include Chrome Remote Desktop, Google Drive, Notepad, and Excel.
Okay, so no program that you develop is without problems, especially on our first iteration. So one of the first problems that we encountered was trying to get information from PDF documents. We had seen that some file information and that we could use was on the PDF documents. However, we figured out that that information wasn't actually stored on the documents and it was more like a picture, so we weren't able to extract that information. Another thing we tried to do was extract information from the inventor files, particularly the iProperty files. Unfortunately, we weren't able to get into Inventor as that's a really difficult task, and there are tutorials, but they're severely outdated. Working with XP instead of Windows 8, which was the operating system we were working on. So, and we also had a problem installing Inventor and getting Excel to work in the right situations, because we had to have a computer while developing that had all of the Inventor files, the right version of Inventor, and the right version of Excel. And we also had problems putting the program in executable format. This is something we had a problem with because we developed certain portions of the program at different schools, because we were working between 2 different schools, me and Riley doing the programming. So we had to put everything together eventually, and that was a problem for us to start with. So some additional features that we would like to add to the program is looking into the iProperties file. If we could get a more updated tutorial and better information on how to do it, we would like to add that because it would add another layer of depth and specificality to our project. We would also like to create a better form if we could that was more modular, that we could say, okay, so for this project, we don't specifically need to put the file name, we just need the file extension. Or some other example like that we could use the form, be more efficient. So the economics for this project was pretty simple. Since we developed the program and the only thing we really need is Windows OS and Excel, which most office computers that we will be running this on have already. So that wasn't a huge deal. And although you do need to have all of the files to be in the same folder, so that's going to take a little bit of time, maybe an hour depending on the file size, and that could be an hour's salary. Although we hope that this will be more efficient than the current method of creating a submittal form, that should help the economics overall. So in conclusion, this program should save EAFAB time and money by creating a much faster way to get their files organized without much input other than just organizing them. And our program is never truly finished because we can update this program in the future to include more things. It doesn't have to be done, it just fits. We also may have some problems with especially updating the operating system as coding does change, especially with a new OS. So stuff like that we may have to fix in the future, but overall it works. So now Riley is going to do an example run of the program. And I'm going to walk through these steps as he does it. Okay, so we have the program and a folder with a bunch of projects installed inside. Okay, we open up the program. This is where you choose the folder which you are going to be assigning the projects from. Okay, it says you. Okay. And
right now it's running, and then it's finished. Right, and it's going to pop up the Excel document. So it brings it up down there. Nice. What is this?
So now what you have is a list of the file names and the file extensions, along with the top where you can say, okay, this was submitted by who, at what date. You can fill that all in, and you can check the information to make sure it is correct. And you have all of the information you specifically need for this project.
All right. And that Excel document is just stored inside the folder. So it will be right here. And you can open that, run that, send that, whatever you need.
Thank you.
Good.
So now we're gonna, if you have any questions.
Will the transmittal form have unique names and titles as you store them in the base?
What do you mean? Like all the inventor parts, the names of the inventor parts that are in the project, those are what
the file type
is used.
The title, Excel title on that file.
It just says transmittal form, but you can save it as a different name if you want, and then that goes along with the entering the header information.
Other than PDFs, were there any other file types you had trouble extracting metadata from?
So basically, what we're doing is we just VBScript has the option to take a file and use the file name and the extension of the file. We were initially trying to extract more data. We were trying to look into the files and pull data because that would help the customer understand what exactly it is. But really, it just acts as a receipt, and as long as it has the name and type of file telling them what it is and what they were sent, it performs this function. So,
tell us about the experience of working with students in another school on a common project. What that felt.
There are sometimes difficulty in communications because like it's always easier to talk face to face than to do it over like instant messaging, texting, etc. So that was a difficulty, but like we're all good communicators here, and we're able to overcome that and still like solve problems that arose like efficiently in a timely manner and like without like arguing or anything like that. Do you have anything to say?
I mean, basically, it was kind of difficult to communicate between those schools, as Vicky was saying, but I think we managed to do it pretty well. I think early on, we also kind of set tasks for each person based on their specialty. Like if Riley and Sam were good at programming, so they would do the major like technical portion, but Vicky and I would be like good at building the methods and stuff. So we assigned their tasks like earlier on, so they would create like less confusion later on in the process.
In your generated document, I saw that you had submitted by, submitted to,
yeah.
The date.
Yeah, it basically brings that up so you can add it back in. Yeah.
And in your example of everything that was blank, would there be a way that I can create my own template to fill that in for me and then pay-driven mechanism template? Or
That's something we had considered doing in our program, just having it like pop up an interface we have to enter it in, but it ended up not working out very well. We decided that pulling up the Excel, there's only like a couple of spaces you got to fill. So we figured that should be our focus, and we tried to make sure it was working.
Yeah, and that's something we could add in the future. And I was talking about the modularity of the program before, changing different aspects of, okay, so you just need this for this project, but you don't need, whatever the file extension for this. So that's something that we would like to add in the future.
Now, correct me if I'm wrong. In this particular case, you guys are starting with a main template that basically is blank, and then just populating the list of whatever the contents are inside of the Excel, right? I mean, that's what your script is doing.
So the blank template is actually stored in the application.
Oh, you put it already inside of the
Yeah, so you don't need to have anything. You just need to have the executable in your project. So you can just run it, and it will automatically have that template. It stores it.
Because for what Willie was saying, I mean, a way we can make that happen is that we basically not have started into the main program. You have a template in which I can have my own, just name it the way in which the program is going to look for such template. So I can have my template, you can have your template. The only thing is that we need to start the list of files in the exact same row. And at that moment, I can put, yeah, that was here, and Willie was too, and then hopefully whatever it is.
That's something that's actually really easy to change, and if you guys want it, we can do it. We're glad to continue working on this project, just to make sure it's up to your satisfaction.
All right.
How do you think using the Luma design strategies will help you not only with this project, but also with future projects?
I think it's a lot of just like methods of thinking of how to think, like a sort of a way of like being able to organize all the brainstorming, all the thoughts into a form where you can kind of like see all the connection, because that's that's kind of what creativity is, and that's what I believe the Luma methods are fostering. Just seeing like previously unseen connections between things, and then kind of closing the gap and creating a product that will do that.
Do you think that'll help you in your approach?
Yeah, I think it could in like certain situations.
So, first, you guys did a fantastic job. I'm very impressed. You guys have talked a little bit about some quality of communications that you had early on. So, if you could go back and start over, or the next time you do a project like this, what would you do different to try to make that minimize those difficulties that you have?
Well, ideally, we'd have face-to-face contact. Now, something we weren't able to do as much, which would have been probably good, is webcam communication. Communication over like a Skype video call. But our labs don't all have webcams, and typically we're in a room that's full of like 30 or so people. So like if we could find a side room that we could go into and just have, because that face-to-face communication is what I think is really necessary with this kind of stuff. There were miscommunications of like what exactly we need to do, what exactly you need to do now, and what exactly I need to do here. So face-to-face communication is really what we'd like to change.
Great, thank you.
And more than me, first of all, congratulations. I'm very absolutely pleased with you here. I do have to go for a public apology to Riley because he sent me an email that I just was got. And when I was looking like, it's like, damn. So over. Is that work? That's not about work. But anyway, one thing that I think is very important, I mean, this particular project, I was very much looking forward for the output of this thing because I am convinced that we are in an impasse, just like we had in 1982 for the ones that we were there. I was not that conscious myself, but in 1982 when our AutoCAD was introduced to our industries, or all of our industries, we went from the drawing made by hand to the drawing made electronically. And everybody said, doesn't matter, all this electronic stuff is going to stay, but we'll never get rid of the handwriting or the handmade drawings, Today, companies do not only not handle it, they don't accept them, okay? And at that time, the way in which people used to submit engineering had to be changed, okay? From okay, I have to make you a list by hand to now a list by electronically. We are in a process in which it is what I call the demise of the 2D. We will not have 2D drawings in the very near future, and I'm talking in the next 5 to 10 years. 3D will be the way in which we need to start educating these kids, and 3D is the way. In 2D, it will have to be just the way in which we told them, oh, let's just go ahead and make lines. Like I was told, just to see, for you to know how drawings used to be made. I am convinced that with the upcoming of different technologies, the drawings will be replaced, the actual 2D drawings will be replaced by having a 3D model that you can just spin around, and whatever it lands, it will show you the proper dimensions that go into that, and that is your engineering. Today, we provide 3D information to burn tables, to make cuts, 3D for pipes to be cut, for everything, and that is going to affect every single industry, not only the manufacturing industry like mine, that is welding, but also something like all-flat, something everybody that needs to actually make a problem. I am convinced of that, and that is going to have to force all companies to find a way in which you can store it, organize it, and for the ones that actually get paid partially, or you get your partial payment upon the submittal of engineering, this is what will be, that's what my wife was saying, says, okay, here's the deal, you know, or this is the point of like that. And this is way more important than, right now, it's very important that we just understand, kids, that the moment that becomes a finished product, it just became a draft. Because we don't know exactly how these industries are going to be moving along to make this cross. This happened in 1982, which you guys weren't even, hopefully you guys weren't even thought about. We were the ones that we were 12, or I was 12, no, 11, sorry. And at that time, I wasn't even thinking about this thing, but the industries had to go through this impact. And I believe that we are right now at the edge of one, just like the one in the 80s. And that's why this right here is actually the way in which people, that we actually sell paper to, we'll stop selling paper and start selling glass drives, you know, full of stuff. Okay, and for that, I really thank you. Great job.
The flash drive, which includes the program on it, and it has a rack pack project on it.
Thank you.
We're going to give that to you. One of the things that is somewhat unique about this class is we really allow the students to drive not only what they work on, but also the assessment process. So as we got through from the very beginning in the first quarter, they had a relatively rigid assessment process to now this fourth quarter that's coming up. They pick their own projects, they pick their own project teams, they define their own assessment methods, so they come up with their own rubric and then assess themselves against that rubric which they come up with. We're giving them the flexibility to be able to come up with whatever they want to work on. I know some of these guys are already talking about, can we keep working on this project for our fourth quarter? So, given that flexibility, absolutely. So that's what we're looking forward to for the fourth quarter. All right, thank you guys. We're going to move on from here to the draftsman test.
Adjust that a little bit. Excellent. Good morning. Buenos dias.
I expect this to be complete by the end of the presentation. Answer key in case you need a little assistance.
Well, good morning. We're the draftsman test, and my name is Lee McClellan. To my right, I have Jared Lynn, Anthony Shamako, and William Freelander. Now, EA Fab, like any high-end quality business, is looking for the best people to employ. And when looking for draftsmen, they need people with skills in drafting techniques, 3D interpretations, mathematics, and more specifically, trigonometric mathematics. Now, the draftsman test is an evaluation of these fundamental skills as well as intangible qualities of employees that EA Fab values. Now, our problem was originally posed to us as being that the test is administered manually now, pencil and paper. But EA Fab was interested in possibly having an electronic test, and that would include timing of sections to be, in order to evaluate how much time an applicant is spending on each problem, and that would help to evaluate where their strong points are further. But through our use of the Luma methods, as you'll see later, we found that this direction was not where we wanted to go with the test, and that the true need of EA Fab lied in another area.
So we were handed an original version of the test they are currently using. The test assesses an individual's skill in mathematics, especially trig and maybe some calculus, sketching, dimensional analysis, and unit conversion. So this is one of the original problems they had. And this problem can assess a person's skill in mathematics. If he is more skilled in, say, trigonometry, then he could tell that using the law of cosines would easily aid this problem. But even so, a person could see that if you draw a line from here, you could use the Pythagorean theorem to also identify the different angles and different sides. So from this problem, we can assess a person's creativity and different levels of understanding in mathematics. This is another problem that originally seemed a bit confusing, but once you take a closer look at it, you can see that by adding up the arc lengths and the sides using radius conversion, then the lengths of the pipe could be easily found. And in these problems are asked a few simple questions about trigonometric identities. Everybody can easily put in numbers into a calculator and get the right answer, but very few can actually understand what a radian is, what sine of 0, cosine of 0 actually means. And in this area, the applicant had to draw a perfect square. Now, Mr. Kuroda stated multiple times that this is the part where you can see a person's ability in getting a perfect square correctly. And in this problem,
see if they actually know what a perfect square means. You know, they're actually given 2 rulers on that point, so they can actually do it here. Here's a pencil, here's 2 rulers. Make a square. Not draw a square in AutoCAD, make a square. You know, you won't believe how many parallelograms and hexagons become a square like this, you know.
And in this problem, the applicant had to find out which line was the longest. Engineering is a precise process. You can't just look, oh, I think this looks longer, and do it. You can't just look when you're doing very specific problems. So the applicant had to actually measure each line using Pythagorean identities and 3-dimensional analysis. And in these problems, we can identify a person's ability of 3-dimensional analysis by finding the 2-dimensional views of this 3-dimensional object. Also in this problem is the same concept. You can't just look at these 2 shapes and say, I think B looks larger or A looks larger. You have to actually calculate and find out the exact dimension and area of the shapes to be able to identify which one is larger.
So in the process of making the new draftsman test, we went to use Loom methods that so provided us. And the Loom methods are designed to take a problem that we were given, in this case, the draftsman test, and examine and see, is what they told us was the issue, is that really the issue, or is it something new? And we found that it was through our different processes, such as an interview with some extraction mapping and a stakeholder map as well as a rough and ready prototype, which you'll see later. So our original idea for the new draftsman test would be a tier-based test, where it would be, you have one section of basic math, like 2 + 2 = 4, 10 × 9, et cetera, et cetera. So very basic. And from there, they would move on to something harder, more trig, more algebra, more calc-based, to see if they would fit in, for whatever way to say, at EAFAB. Another idea was to have a multiple section test, which would be a standard test, which we all see, which only students see at school, multiple choice and free response, as well as a 3-dimensional analysis. We also thought of including a time constraint in both versions of the test, as well as a very challenging inventor model, but throughout the Loom process that ended up changing. Our first step was we wanted to talk to Mr. Kuroda here much more in depth about what he really wanted to find. And our goal through that was to see what was expected of the draftsman, what skills were needed, what knowledge of software, what they really had to show, and what was like the true purpose of the test. Was it just to see what they can do, or was it to see the process, to see if they know what they're really doing, to see that they can learn?
This guy, he just wrote the curse.
Then we also want some more specific questions, like what do you think of the time constraints, the types of questions we had made up, and the idea of the tiers. After the interview, we found Mr. Kuroga was looking for people who would work hard and were honest and they could show their integrity. So through that, we learned we had to remove the multiple choice section. There's still one or two, but they include explaining why you chose that answer. We added some new problems which really tested the diligence, which Mr. Kuroga spent a lot of time during the interview process doing. You'll see that one later. And we did keep a two-tier process, which was straight fee response, math, some basic identifying what side would be the object of this, as well as a 3D modeling, very simple 3D model, and a 2D sketch. We after this, we did the abstraction ladder, which was to see what we want to achieve and how we would achieve it. So starting at the center, you see create a better draftsman test. We move up from there to the next step. Why do we want to do this? It would be to employ people who show the aptitude to learn and who will not cut corners. The next would be, how do we do this? We do this by evaluating the diligence of the employees, and then this continues for however long we feel it's needed or it takes to get to a final answer before we just keep repeating our loop. We do the stakeholder mapping just to see what we did and who this was targeted for. So it started with Kuroga as our main client. From there, it's spread to the draftsman, to the factory workers, and people outside, people at technical schools who teach the skills. So that's it.
All right. So the final step, or the final process we use to arrive at our final draftsman test is called a rough and ready prototype, which is basically just a rough draft. We decided to go with two tests, a two-test system. Test one had three main components. It had free response, three-dimensional analysis, and a personality test section. And test two, or if the applicant were to pass the exam, then they would move on to test two, which really tested more two-dimensional analysis and three-dimensional modeling in Inventor. So the test one again was comprised of multiple sections. Now the free response had subsections in itself. And one of the sections was math-based. We assessed geometry, trigonometry, and dimensional analysis, like unit conversion. And these are just some example problems that we had. The problem on your right would assess if they can do basic trig, and then the problem on your left would assess if they could prove why one is bigger than the other or if they're equal. The next section of the free response test, we wanted to test diligence. This is a very tedious problem. Basically what it's saying is you have two people, Wolfgang and Brunhilde, we chose starting at different points. They walk at...
This is the best part. I love it.
And they walk in different directions at different angles, at different lengths. And to find out how far they walk, you have to actually draw each diagram, find the measurements. And this problem just really tests, will the person demonstrate diligence to work all the way through? Will they cut corners, or will they do it the right way? Which, if they don't do it the right way, then that just shows that they're not diligent enough to not cut corners. Which, in a company like this, you cannot cut corners. Otherwise, results would be very bad. The next section of our draftsman test was, again, three-dimensional analysis. We just gave them a 3D figure and asked if they could draw what it would look like from the top, from the front, and from the right. Again, basic engineering qualities. And then the next section was logical reasoning, just to see if they could, to see if given like 6 or 7 facts, if they could figure out who did what, just based on facts. So this was an example problem where 5 people took a different cruise in a different year, and a bunch of other tricks, and we wanted to see if they could figure out which person took a specific trip in which year. Because if they could do that, then they could think logically based off of
not that much information to arrive at an answer. And then one of the last sections in the first part of the draftsman test is a personality test, where this was really just to see what people are like. We really wanted to try to eliminate the people that might not best be suited for the job because their personality might clash with other workers or something of that nature. The test two, again, included a 3D modeling where we would give the person this 3D model here and say, okay, make it an inventor. As simple as that.
And a cow.
Yeah, and a roll. And if they could do that, then that would be great. And the way we test it is there's a thread in the center of the bottom circle. And if we would give them a bolt, if the bolt could screw into it, then they did it right. If not, then they did it wrong. And then the final section just included two-dimensional analysis. We're seeing if you could draw like the 3D views based off of 2D pictures.
I'm just going to pass this around. This is a 3D printed model of something that we did on the Inventor Autodesk program. Now, the final product was really, the goal in mind was something Mr. Kuroga had said early on. He said, I want to see the man. So what we're trying to evaluate is not only the school tricks, the little mathematic shortcuts, but really the content of a person's character and see if we could build upon their knowledge at EA Fab and make them into a productive draftsman. First part of producing a test, of course, is you have to have the answers. So what we did was we tried to have a comprehensive guide on our answer key as to the directions that an applicant could go in solving a problem. And not one answer is correct, but we really wanted to see how people approached and attacked a problem because even if they didn't come up with the correct answer, you can see parts of the work that if they had some semblance of that or some new approach, that would say a lot about them as well. So we ended up keeping a lot of the mathematic parts of the original draftsman test because we think that Mr. Kuroga had a good idea of what he wanted an applicant to know specifically in terms of trigonometry and basic algebra and math. But where we really improved the test was in the area of reasoning and I guess logic-based questioning. And what we have here is we took an adaptation of the original problem that Mr. Kuroga had on page 5, and we changed it so that the applicant would have to not select from predetermined choices, but they would have to draw the answer themselves. And then page 6 was a problem that we added on another that assessed another aspect of trigonometry that the original test didn't have. So now page 7 is kind of our pride and joy, I guess. Wolfgang and Brunhilde, the Germans walking in opposite directions. Now, what we really liked about this test, this part of the test, was the way that you see this model or this diagram had to be drawn for page 7. And the problem itself was very tedious, very time-consuming, but we wanted to see if the applicant had the diligence and dexterity to truly map it out, and we wanted to see how they approach that problem because there's tons of room for interpretation. And the way that someone goes about tackling this problem says a lot, not about just their mathematical ability and their academic skills, but really the way that they would approach a real-life problem. Would they have the patience to approach a problem in a difficult way and just really map it out, and just says a lot about a person that they can tackle that. Page 9, we offered a mathematical explanation for a problem that already existed. Now, page 10 has some logical problems. You're asked to draw 4 lines to attach 9 separate dots in the top.
And this can be a very difficult process. We came up with one answer, but we also just recently discovered another one. And that's the beauty of the problem. What we came up with on the answer key is not necessarily something that an applicant would come up with. And the work that they show, even if they don't get the one answer that we provided, can say a lot about what their mindset is in approaching these problems. Then below, the task is to put X's in the grid so as to make, or 6 X's, so that none of the X's are in a row, 3 in a row. And once again, the way that someone, we had some people take the test, and they came up with all sort of things. Just the work that they show, even if they don't come up with the right answer, it shows to us that they made an attempt, they tried out something new, and the right answer is not necessarily the most important thing. Over here on page 11, this is one approach that we had. This is a very methodical approach to the logical problem, where we're given certain pieces of evidence and we're asked to find which person took a specific cruise in a specific year. And there are plenty of ways to approach this, but the way that someone would attack this problem, once again, it shows their ability to think and think logically, and just tells you a little bit about how they would approach things in real life. And page 12, we can't necessarily call it a personality test because by law, we're not allowed to, as an employer, quiz you on what you're like. So we're calling this an evaluation of intangibles. And so we're circumventing.
Way around.
Yes. So the whole point of the test really is to evaluate your intangibles. Yes. So we responded to Mr. Kroger's need for intangible quantification. And so it's a personality test. It's a Coke or Pepsi, if you heard of that. But it's so we don't hire any weirdos. Don't
put that on the test.
No, that stays here.
Money writing.
So
Get out the weirdo. Get them all out.
So Mr. Kroger also expressed a need for weeding out people who maybe in the interview process said, yeah, I can use Inventor. I can use this CAD program. And he wants to be able to say, hey, show me, prove it to me. So here is our 3D printed model. What we're going to do is hand them this piece that's been passed around, and we're saying, here's a ruler, produce this in a computer program. And that'll obviously, if you don't know how to use a thread tool, you don't know how to construe things, you don't know how to make a hole, you don't know how to chamfer, you just, it automatically weeds you out. And don't lie to Mr. Kuroga. He will catch you. The draftsman test will catch you. So then page 14, we created on Inventor. You can see this is what the program looks like. If you look at 14 in the bottom right corner, that's a 3D model that we created. And then you're supposed to draw the top view of it and draw an isometric view of what that little drawing we've given you. So it evaluates your mathematics, content of your character, your dexterity, diligence, your approach to a problem, and your ability to 3D model, all of the things that we expect a draftsman and EA Fab to be able to do in some capacity, and also tells if you're a weirdo or not. So thank you very much.
From anyone? Yes. This is really a two-parter. So you went to your client, and your client says to you, these are the things that we want to measure. What's your impression that's most important for the employer? The content knowledge, knowing the trig, knowing that the subject matter stuff, or the evaluation of the intangibles. I mean, those other factors, creativity. What do you think the balance is, 50-50?
I would say the top priority for the client would be, doesn't want corner cutters, doesn't want someone who's going to cut corners, because the nature of this business is such that a cut corner is, cutting your income. It's very important that I think the content of the character is most important. EAFAB can work with people who maybe lack in the content area, but it can't work with people who don't want to learn and are going to cut corners.
So now, here's the second part, sorry. Here's the second part now. You're ready to go out into the world soon, next year. So what do you think is most important for you to gain through your high school experience? Gaining that content knowledge, or gaining the other aspects, working together as a team, working on your evaluation of your intangibles and the content of your character? So what do you think it should be when you leave high school? What's more important? Or 30-70, 50-50, what do you think?
Yeah, you just need a healthy balance. This class works on, I think, a lot of the your ability to learn how to learn, your response to real problems, and other classes prepare you with the content and everything. Up to this point, it's been a lot of content development, but I think everyone here, especially in this group, I think have a nice balance, and it'll help them going forward.
Were you going to add something? Okay. Thank
I
you.
have two quick questions for you. First, though, here's the going process. Here's the so great care to listen to your client and develop something so that it's what the client is looking for. So my question is, how are the questions generated? And doing that generation, were you required, because we're talking a lot about science, technology and stuff, were you required to delve out into other disciplines? Because some of this, the intangibles you're talking about, the behavior of the character, really speaks to things a little bit outside of that, the humanities, and sociology, psychology.
Well, for a lot of the free response questions that weren't originally given to us, I actually developed some of them, including the Grunhilde one. And what we as a group wanted to do was just try to create not necessarily problems that were very hard, but problems that required a lot of diligence. Because again, the clients that EAFAB hires can't cut corners, and if they cut corners on a draftsman test, then how could they be trusted with like a real product for the company? So we just tried to get tough problems that made you think, as well as assess basic math.
And you consulted the resource that you guys just sort of brainstorm those from your own devices.
We, for the most part, brainstorm them from our own devices, but we did some research online, looking at different websites that had different examples of different questions, and tried to take what we felt was the best and kind of merge them.
So one of the things that we talked about are habits of mind, things like perseverance, empathy, diligence, all of those types of things. If I ask each of you to give me one character trait or one habit of mind that you think is most important as you go forward, what are you going to take with you?
Discipline.
I would agree with discipline as well, because yes, knowledge is good, but if you don't know something, it can always be taught. You just need to have the diligence and discipline to be able to learn and to be able to admit you made a mistake if you did. Because that can't be taught. That has to be your second nature.
Just as Will said, diligence, discipline are probably the most important things. Even if you don't know something, if you can sit down and force yourself to learn something you don't know, it will be better than just something else.
I agree with a little discipline.
Thank you.
How do your peers at school look upon you in this project? What do they think you're doing, and what's the reaction that they have about you doing this?
They think we're missing school. They really want
So do their teachers.
But yeah, I think they you're in the STEM class. Oh, wow, okay, well, you must be well versed in math and science. You must be a good
it's stuff that we've been doing all kinds of stuff for a couple of years, not 4 or 5 years at least. And most of the people there know what it is, and they think online just need to go at math and science, which you do need to have. You really can. Like a D student science math, but it's not just that. They know you have to be good at public speaking, you have to be able to think outside the box with stuff like this.
How did you guys know you had a quality test by when you were finished?
Well, we actually gave it to a few of our teachers too. And at first we originally thought it was going to be too long because the free response section is 12 problems, and some of them take more than 5 minutes to do. So that was our main concern at first, was is it too long, is it too much? But after performing a couple of tests, we realized it's a perfect length. My physics teacher did it in about 30 minutes with no problems. And the way we judged if it was quality or not was if there were multiple ways to get to an answer to see if someone could just think a different way than the normal. Or, and we just wanted to make sure that they could do the basic math required for the job. And if they could pass the math section and pass the logic section, then we felt those were quality questions to ask because it was specified.
For completeness, when you were buttoning up your presentation, be sure to include that last nugget around the testing of the test, what your presumption was about the length and what your finding was. That's called for in this looking understanding. You made the prototype, and then you took the discipline, went back and looked at it carefully, and then you went back and understood what you learned from what you looked at. That's the virtuous feedback loop that you're leaning into. So make sure that's captured so when you throw this out, it's really compelling. Good stuff.
We're going to our next project, which is shipping costs. I'll take. Wow, the peg gauges, they don't have much. After will be.
Should I get
Yeah.
What's up?
Have at it. Gotta stuck up. Go ahead, when you're ready, guys.
All right, so we're going to introduce ourselves first. So I am Christian Deischer, senior at Southpointe High School. I'm Evan Gordon, and I'm a senior at Upper St. Clair.
I'm Cambry Love, and I'm a senior at Southpointe High School.
I'm Jacob Tsai. I'm a senior at USC. Okay, so today we're going to show you the shipping cost solution that we have created for Ms. Kuruga. Okay, so the problem definition that we had that she gave us was to find a faster way to calculate the shipping cost that she had set up. So what we did was we created an easier way to insert these variables that she had for the shipping cost, and we put them into this equation that we created, and it's, I guess, a simpler way for her to figure out the final cost of everything. So what we used for our Luma method, the big one that we used was a stakeholder map. And what a stakeholder map is, it just shows all the stakeholders. And first we have our primary stakeholders, which is EA Fab and Ms. Kuruga, obviously. And then we have like the secondary, third, so on stakeholders that are used within this problem definition and the solution that we have. So we have clients, truck drivers, gas stations, etc. So the main factors that we used is distance, expenses, drivers, and truck limitations.
We had a long process. First, we had to figure out the different variables that were used for the truck driving, like how many hours they were going to go, where they're going to stay, how much food they're going to get. So then we put it into a long written out equation that just added, subtracted, multiplied. And then we put it into an Excel sheet, which showed all the variables, but like added them together. So like the eating, drinking, where they're going to stay is all put together. And then like the gas mileage, how much it's going to cost, how far they're going to go. And then a different one, so like how far they're going to go, but like the routes they're going to take. So we put that into an Excel sheet where you can manipulate. And then it gave us our final program, which we put in, which would add everything together and show you the end price. So some components of the equation. They are allocated $35 a day for food. So we took 35 times V, the number of days in the trip. And then they get $20 an hour until 40 weeks, which is a full week or full time. And then, so we took 20 times W, which is the hours driven before the driver is paid overtime. And then 30 times X, this is X times the number of hours the driver works after reaching like overtime.
0.063y, where y equals miles to be driven, covers the maintenance cost of the truck. And we made that per mile cost just to make the estimates closer. And we found this based off last year's estimates of $1,500 in maintenance costs and divided that by the total number of miles they drove last year. Similarly to the last one, insurance was also $1,500 last year. So we just used that and divided that by the total amount of miles that they drove last year, so it's also 0.063y. 0.026y covers the cost of tolls for a 4-axle truck with an easy pass per mile. And we found this part of the equation by using last year's estimates of $600 spent on tolls, and divided that by the number of miles that they drove. And 0.3228y covers the cost of a new truck using the depreciation of the old truck. So they currently have a Ford F-450, and they told us after 4 years of life they want a new Ford F-450. So we found this cost based on the price of a new truck subtracted by the residual value of their current truck, and divided by that by the lifespan
like the total miles that their current truck drove. And so a new truck would be 52,500. The residual would be 21,500. Subtracted the two and divided that by the life of the current truck.
After this, we tried to determine how much that they would need for a hotel fee. So we averaged up all of the hotels from Holiday Inn within Pennsylvania and surrounding states and divided it by the number of hotels to get 112.24. And because if the trip was only one day, they wouldn't need a hotel. We did B-1, which is the days -1, to determine how many days they will need to lodge. After this, we had to calculate the cost for diesel fuel, or the cost for the gas. And we did this by dividing the number of miles by a factor by the miles per gallon. But as the weight increases, the miles per gallon decreases. So we found that during one example trip, the miles per gallon was only 6.6 miles per gallon, but it is generally 10 miles per gallon. So we did the 10 minus 6.6 and divided it by the total weight, which includes the trailer. And we did that to get the miles per gallon. We got the factor 0.0017 and multiplied that times the weight to get the amount miles per gallon decreased. Then we just added up all of our factors that would come into calculating the total cost and added them together to get the final total cost of the shipping. And we had he's going to bring up a program, our finalized program, which all you have to do is plug in the variables that you want and it'll calculate it. And that's the total cost. So it's fairly simple, and if we need to modify it, it's just an HTML document that we can modify for you, or if you have someone in the company that is capable of modifying it themselves, we can explain what we did and which factors go into creating the total cost.
We also have an Excel sheet. So if you do not know HTML, we just have this, and it's nice because it shows you each cost individually, and it ends up adding it all together. So either way is fine. We just have this as a backup in case anything happens with the program, or if you can't change the code, this is just a little easier to change, manipulate the equation, and it shows each individual cost. Any questions?
So do you have then somewhere else in this sheet, the cost of the new F-450 and the residual value and the insurance cost? Is that somewhere else that would be a component of the spreadsheet that, say, Mr. Quiroga would modify, but somebody else would?
Well, we don't have that on the sheet. We just have that on our PowerPoint, but we derived the components of the equation using.
So this just goes through and uses the coefficients of the equation into here as opposed to the things that went into the creation of the coefficients. Correct.
We have a first model of the Excel that has, say for Claudia, if she wants her own page, she could have how much she pays for workers, which inn she's going to use, and which truck she's going to use at the time. If there's a trailer for just Claudia's page, but there can also be another page that you can pull back, and it can have all the calculations that anyone can change. Like if they're going for 2 nights now, the person who she hires or wants to do it for, they can just add another date to it. So it'd be easier for you to have your own stuff that you said, like the pay for everyone, and then another page where no one else can see that you can change just the shipping details.
What has this experience taught you personally? What did you get? What was your take?
Our experience is mostly research-based and asking questions and just looking stuff online. But there's also like collaboration. We had to take different parts of the equation. So it just taught us how to work together whenever we were away from each other and like communication mostly.
Do you guys have a place in this in all your costing for unforeseen stuff?
We do not, because we won't be able to account for unforeseen stuff.
So for example, maybe like a little buffer just in case that the how to say the food hits the fan. That is not a bad word. What happens when, I mean, you have, for example, something that I was unforeseen, stuff like that. I mean, in the original thing that we had, we realized that sometimes this actually is going to be fairly accurate with the cost that is going to be if nothing happens, if everything goes as planned, which thank God it is most of the time. But every once in a while you have something that I don't know, a tire blew up and the jack broke and at the same time they tried to lift it up, and then I don't know, lighting came in and cracked the thing. So every once in a while we have some of those expenses that are, and sometimes it would be good to maybe add to this thing a little row for VHF.
We had a place that allocated for maintenance and like insurance and like extra, like, so if you had an overall price, you could allocate like $1 on extra shipping, each shipping thing, so that it adds up in the end, so you could have a certain amount at the end extra.
The one thing that we noticed is we couldn't account for it, like we couldn't create a coefficient to determine if the poop hits the fan. So we could add another variable that says like $200 for a new tire or $1,000 for a new axle or so on, to just add on, not like just add on the whole cost, not just a it wouldn't be like a per mileage cost, it would just be a full sum, so like $200. We could add another variable slot where you just put 200 and it just added on to the original cost.
Yeah, we could add a fixed cost to account for stuff like that.
Was it one issue when we ran into the weather?
Yep.
Just stopped and we had to go to Delaware. Normally we wouldn't have, we had to go to Delaware because of weather.
Mm-hmm.
There was a percentage or something of that equation as a buffer.
I'd be curious what you guys' reaction to what you're hearing.
I'm very impressed. But these guys did a wonderful job. They did their homework.
Nice show. One last one.
Yes.
Adjusting the price of diesel. I mean, particularly when the petroleum is going down or going up or bouncing up or bouncing down, that you normally, that will be just whatever is the current, that number 3.
We have.
Yeah, every time we discussed this, so every time I'm in it, right now it's changed, I don't know.
Yeah, it's a variable. It's not fixed.
You adjust that and everything.
Yeah, like you can adjust it.
Any other questions?
Okay. And we have a couple of minutes before the next group starts, so if you need to take a quick break, we'll go right into the last session before lunch, which will be on the pipe rolling gauges. So we have about 5 minutes before they're ready to start. So if you need a quick break, we can do that now. And we'll come back at 10:45.
Not yet, no, they're coming. They're going.
This has the program.
Oh, thank you so much.
How about make it a little more bulletproof.
Okay, well, thank you very much. We're going to move on to the last presentation before lunch. If you notice, as we've gone through these presentations, they run everything from accounting to computer science to education and mathematics We're moving into the next few presentations, which are much more along the manufacturing and engineering orientation. So we have the last group before lunch. We'll talk about the pipe rolling gauges. After lunch, we're going to get into the pipe rolling machine and the digital displays on those. And the last group will show you a panel which they designed that carries a rack which carries some of these panels. So, you guys are up.
So we're the pipe rolling gauges group, and I'm Russian Spry.
Sarah Lipinski.
Daniel Kuroda. Justin Scott.
Okay. So for this problem, we worked with Paul, and our problem was to build a recommended tool that would measure the internal radius of a rolled pipe. So how do you roll a pipe? Now, EFAB has a machine with these 3 rollers, and they're in a firm position. So it kind of creates a mold. And when you put the pipe through the 3 rollers, and you start rolling the rollers, it kind of curves the pipe and forms this continuous radius to form a circle. So this is a geometry refresher. So these are a couple of equations you can use to find the radius. So you find it using circumference, which is 2 pi r, the arc length, which is the circumference times the angle theta divided by 360 degrees, the area, which is pi r squared. And this kind of got messed up, but it's the square root of 8rx minus 4x squared. So this is what the current tool looks like that EFAB has right now. There's a horizontal bar and a variable screw. So when you're measuring the radius, you have to put the 2 endpoints of the bar, and they have to come in contact with the pipe. And the screw has to be tightened or loosened so that it also touches the point over here. After the screw touches the point, you have to measure the length of the screw itself, which we have x, and you put it into this equation, which is 4x squared plus c squared divided by 8x. And c is the length of the whole bar itself. Now, we derived this equation using the Pythagorean theorem, which is a squared plus b squared c squared, and this is our a squared, b squared, c squared. The current tool is functional. It does find the radius, internal radius of the rolling pipe. However, there are some drawbacks. Primarily, the tool is very tedious to use. As I explained before, the screw has to be tightened or loosened so that it touches the tip of the pipe, and then it has to be measured using a caliper. And then, only then can you find the radius. Now, to do this once, it takes about 2 to 5 minutes, an average, just to do it once, so it takes a long time. Second, the tool itself, as some of you called it, is really heavy to be used promptly by all. So in our final solution, we wanted to eliminate all these drawbacks. We wanted our tool to measure not only the internal radius, but also the external radius of a pipe. We wanted our tool to have the same or better accuracy as the current tool. Just to put things in perspective, our tolerance was just 1/16 of an inch. So I had to be that precise. And we also wanted to eliminate the tedious process. And lastly, we also wanted our tool to be light enough to be used by all real promptly.
Okay, so once we knew what EFAB wanted for their gauge, we had to go through some methods to make sure that the problem that we were solving was the real problem, and that there wasn't some other underlying problem that we needed to resolve first. And so we went through a couple of methods in our design process, including interviewing, abstraction laddering, stakeholder mapping, and referee prototyping. So here's an example of our stakeholder map. And as you can see, we had to account for all of the people that are involved in this pipe rolling process, whether it be actually rolling the pipe or EFAB, the company itself, or the people who ship the products that are made of this pipe. And so we had to account for all of them and track their relationships in the stakeholder map to get a better idea of how we would solve the problem. And then we did what's called an abstraction ladder, where you take the original problem statement and you move it up and down in abstraction, asking how and why repetitively until you come up with the source of the problem.
And so we interrogated the original problem statement and found that it was pretty accurate as to what the problem really was, and that our problem statement was in what ways might we make it easier to measure the radius of the pipe. So going through this process, after we had determined what we needed to do, we decided to do some rough and ready prototypes to get our ideas out. And so this was just one example of a tool that we constructed roughly, and as we'll explain later what this exact tool does.
All right. And some of the investigating solutions that we looked at, one of them is an existing product. This is both an inside and outside radius gauge, and EA Fab already purchased it, and the price can range from $170 to $200. All right, to redesign the purchase tool, we were thinking of bringing it up to a larger scale. It's like this big, but if we bring it up to a larger scale, it can bring a greater accuracy to measurements. And the material it's used out of is aluminum, and it's really, really flimsy. And we're thinking of making it more stability with a different material like basswood. And we were going to add grips to hold it, so you don't have to just have it with one hand. And we were going to think of maybe adding a more exact contact point. The point at the end of it is nubbed, which it doesn't give you really precisely. Another one is camera software. In case that EA Fab grows and more pipes are being rolled, the process needs to be automized for efficiency. And the process this camera works with is camera would be mounted, and there would be a calibration plate that picks up the measurements, and photo would be taken, and the software measures would be taken. And it's a custom-made program for it. Some of the pros and cons for this is that the software would be relatively easily to teach, and the operator essentially just have to push a button, and it could be used for multiple rollers. Now the cons for that is this is expensive, it's not cheap. And it's also maybe difficult for being accurate, because if the calibration plate is misplaced just by a little hair, the measurements won't remain the same.
Okay, so throughout this process, we did do a lot of mathematical exploration and tried a few different solutions, and some were proven to be better than others. One tool we tried was this side measure tool, and pretty much what it is, it would be 2 bars set at a fixed angle, and there would be a screw, as seen through here, that you can adjust, and that would be your X. And as you, depending on the length of the X, would give you the length of radius. And we just, after we came down, and after we determined the math behind this solution, we ran into a problem with the domain. The length that the screw X would have to be was not very plausible. We would run into problems like for a 60-inch radius, the length of X would have to be 50 inches. So the solution wasn't the best. For this one, we had, this is the inverse of what they currently have. It's the inverse of what they currently have. So instead of it touching a cord on the inside of the circle, it would be touching on the outside of the circle. So this one, we ended up having help from a friend, Jack, and this one the math, we had to make a lot of assumptions, so it really wasn't the best, because this length, the top one, this would have to use this one. The top length would have to be perfectly, everything has to touch perfectly in order to assume that this length is your cord length and give you the radius. If it is not perfectly touching and perfectly assumed, you would get a lot of inaccuracies. We have a few final solutions. Here's our external radius for our prototype. We only need a prototype for this one. We would later make it out of different materials, and we would later bring it out of different materials and also add a digital radius gauge. Now, this one, it's nice because it can measure both the inside and outside radius. It is relatively easy to use and inexpensive, durable. So when you're in the shop, you can just throw it off to the side and it won't technically, it wouldn't break. The measurements, it's kind of difficult for the measurements because the angle has to be perfectly 90 degrees. The screw has to bisect it perfectly in order to make our assumptions. If not, again, you would get various inaccuracies. And again, you run into the same problems with our current tool, with the positioning. If it's not perfectly tangent to the circle, it will result in inaccuracies.
So as for our final solution for the internal radius gauge, here it is. We pretty much redesigned the curve. We realized through all this mathematics ratio, we really spent most of our time, that we're just kind of moving this chord length that we were talking about up, inside, outside, wherever. We're moving this x value we're measuring from the chord to the radius in order to just kind of move that around. And really, why would you when you have access to just that initially? So pretty much here we have this chord length here of exactly 24 inches, and then a digital display to measure this exactly x. And then once you get this x value here that measures from this plane here to the pipe, you plug it into the formula and it'll get you exactly the radius. Also, a pro of this, it's much, much lighter. Feel this is significantly lighter. The other one, you can feel it's maybe about 15 pounds. I don't feel like I'm exaggerating. This one, I believe maybe 2 pounds. So it's a significant difference. It's made out of aluminum, and the big key to this is it digitally measures the distance. So this, instead of having to use a caliper and a whole step where you have to take out a screw, move the screw in and out until you hit the pipe, and then readjust it and measure that. This eliminates that step completely from the process and taking away time. So when it takes less time, you save more money in the overall process, which is our goal. Yeah, so just as I was saying, yeah, the other pro we have is it has extension kits. So a lot of people may ask, well, how could that possibly measure something that could be longer? So I'm going to pass this out here. These little extension cases, such as get the big one. Something like this. It's simply you just remove that top part right there, and then put this in inversely, screw that back on, and now you have a different length that you can measure and keep measuring longer distances. So therefore, we can measure pretty much anything. And also, we have a chart that pretty much tells us the radius, and then from there, the amount of distance it needs to be, and then the value that it needs to display on that gauge, and it'll be a perfect radius. There can be a couple of inaccuracies, and it is slightly fragile. So I mean, we're adding a new step with these extensions, but we're eliminating the other step of having to remove the screw and really fishing with that. So we feel like we're saving a lot of time, and these extensions they really help the car. Can I see that? As I said, instead of all that process, you just unscrew this, take this, which is the same end, and screw this in. That's perfect. And now here you go. Something you can measure. It's the move around in and out. If you want to see this again. Anyway. So these extension pieces are really the key. Also, if you've noticed, there's a level. It's not your regular line. This is a level that measures if it goes inside or outside this way, or up and down this way. Another problem we see is something very heavy. Bobby has to put this up against the pipe, and he could be tilting one way or the other, and he can be tilting up and back. So therefore, we're eliminating that if he's using the level, and it's much lighter, so he doesn't have to really struggle to put this up there. And as long as he's hitting, just as we're saying, this middle of this pipe right here, we should get a very accurate read on this measurement. Yeah, so conclusions. This electronic gauge costed us about $20, and we have a replacement battery that should last a year. So in case it does fall, it does break, it's only $20. You buy a little epoxy and adhesive that just puts it right back in there, and you have another tool brand new. So as we said, the current tool takes about 5 to 7 minutes to set up for one. And with some of the type of panels that they're dealing with, we can have different radiuses. You have to do that process many times. So here we're eliminating that completely. We can save a lot of time. And lastly, we'll cut down rolling times, which will help them save money. Any questions? Thank you so much.
Did you go into anything like calibration? Because a lot of times in devices similar to digital gauging, laser, whatever, there's calibration requirements.
Well, on this gauge, you calibrate by zeroing in on the zero. So one problem we had was as you pull it back, you do get a negative number, and that negative number, the display, is just saying how much it has traveled. So instead of setting it in a way that you would push it forward to give you the distance, we set it in a way where as you push in, it kind of locks into place, which is a constant zero. And I mean, as you push it in, it will always give you either 0.01 or a negative 0.001. So it's very accurate in that 0 point. So from there, the measurements, they seem to be very precise along the way.
And I'm assuming you mentioned you epoxy that in place. How do you assume that that position of the epoxy doesn't matter then in regards to calibration?
No, I mean, it's just measuring the distance that it's traveled, the change in distance. And that front part, it's difficult to explain, but that front part there where it actually, where it starts to head out, it has a little ridge. And that ridge, we put it exactly flush with the front of it when we epoxy it and we let it sit there. It is a fixed point.
Very impressive work. It was interesting to me, you mentioned that Jack helped you with some aspect of your work. And I noticed Eliza in one of the earlier groups that she brought her younger brother in to help. Did you find that you identified students who had a certain expertise within the larger group? Did that happen a lot, that you consulted with other students outside your group?
Definitely. I mean, Pat DeMarco, we consulted with him since, as you will see with his presentation, it is very similar, not very similar, but in a lot of ways similar to ours. So I did go to him a lot. And then, like I said, we went to Jack, and we did go to our math teacher, Mr. Miller, our, what's his name?
Yeah, this math is very experienced. Teaches college level mathematics at school, and really consulted me. Jack here is very good at math. We're good at many other things. So when we have such a hard problem that we're trying to figure it out, it helps to get a different set of eyes on it.
I can speak to that in classrooms too. I'm sure the same is true at Fayette, but that happened a lot in my room, where kids were helping each other on the projects. And we were pretty deliberate about being open with what each student or what each team was working on. So everyone was generally familiar with each other's problems, and they had some ideas that were openly shared. It was really good. I mean, I thought that was one of the things we really fostered during the second project that didn't happen as much in the first project.
I have a question. What do you think, Bob? You use it every day. That's
yeah, I grabbed a hold of it so much later. I like the concept of, it's a really good idea.
You think it saves you anything?
Oh yeah, that would save me a lot of time.
And by the way, this is Paul Show from Bob, and Bob is the actual man that does all the measurements of the pipe rolling. He's the actual operator of the thing, because it was very important for us that this tool, which actually is I'm convinced as to the savings that it's going to bring, but the number one final evaluator was the same as this man right here. You know, doesn't matter what I think. He is the one that is going to be handling it. Paul is the shop foreman. He is the one that set up how are we going to do things so in the shop. And right here, the two actual users of this tool. And hopefully we'll go ahead and start using it and actually measure the impact of it.
Kind of bring something that they had mentioned a little more into perspective. When you saying on our original gauge or our current gauge, about 5 to 7 minutes to set up. That's something that's one thing we roll in one pipe. The panels we build, some of them have in excess of 40 pipes. Those 5 to 7 minutes turn into hours of off time just setting a gauge rather rapidly. Something this quick of the time saved alone.
You're talking about 40 pipes that all have different radii.
Oh, I've never rated
40 different radiuses in an amount of sometimes probably 90, 100 and some pipes. And it to be rolled. But in that mixture, you have 3 of one radius, 4 of that, 1 of that. Sometimes it's 1 of each. And those jobs are the ones in which, for example, the parts prep area. Going a little bit back into the point where we were talking about the number of hours. When you see a disparity in hours, and you see a sidewalk panel versus a roof panel, which again, I'm expecting for people to know exactly what the difference. But basically, a sidewalk panel is 7 pipes all with the same radius. So what we will grab our tool, set up once, and make sure that all the pipes he rolls have all the same radius. Which is not much of a big deal. That means on the whole panel, the setup time is only once. In the roof panels, you have, 40 different pipes where you have 36 different radiuses to create the same panel. Well, the parts prep time on that particular type of product, it becomes astronomically different in terms of just parts prep, And when we don't have to now, right now we have to create a pie chart that basically specifies the number of millimeters, and that's another incredible improvement on what this group has been able to create. At this moment, the accuracy that we can handle on the gauge is to a millimeter. You used to be 16 to 10 inches, basically, was just not good. I didn't. And then we bring my product down to a millimeter, and now we are to 100 millimeter with this particular tool. So we now actually put a little bit of a work on the engineering side, so we can actually put on that thing to actually do 2 extra decimals, where we can actually take advantage of the accuracy that these kids are bringing to the table right now.
But you just completely messed up the labor cost.
Yes, sir, and you're welcome.
My question is rather simple. So I'm the college recruiter, and it's between all of you getting accepted into the college for whatever scholarship it might happen to be. How does this experience give you a different story to convince me as to why we should take you and not somebody else who has equally as good grades as you?
Well, I think, especially for me, I'm planning on going into design, and I think that working through these problems and having real-world experience with designing something that's for people that actually are going to use it, having that experience and being able to relay that to a college admissions officer would kind of give me an edge as to explaining that I've done it and I know I like it and I'm really looking forward to doing it more. So I think that would give me a little bit of an edge.
I would agree.
You also have to work with kids in the like wood shop, metal shop, and some of the other classes to design, build, calibrate that piece of aluminum.
Well, we worked in
prototype.
We worked in both shops. Well, in our shop, first we had the material, the aluminum, and we picked it out. I mean, it's great. We have all these different resources we can use. From there, we kind of conceptualized what we wanted to do with this. We liked the weight, we liked certain things. And in South Fayette, they machined it, and they really brought to life what we had thought of.
Okay.
And then it came back to St. Clair, and we kind of just put it all together.
Somebody said, let's cut those notches in that piece of aluminum. It'll still be strong, we can be lighter.
Correct.
Yeah, that's pretty cool.
Do you have a new appreciation of
what manufacturing is now and what you can produce in your tech ed programs?
Yeah, definitely. I never knew we could do all of this. I mean, we just got new materials. We got 3D printer, CNC machine. So now it's really exciting that we can make so many new different types of things that could find real solutions for real world problems.
So you have, you arrived at aluminum. Did you consider other materials? How did you zero in on what to use? And did you happen to pick a certain recipe of aluminum, a certain alloy of aluminum over another before you came up with a final construction?
I wasn't there when numbers picked this, but aluminum, I don't know what type of alloy this is either, but I think they just found, right? You guys found
Out of all the resources we looked at, we wanted certain things, certain sturdiness, certain shape, certain weight, and of all the resources, this was the best, and it's a very, very light material. It's still very strong.
Yeah, aluminum is used in car chassis to make cars. And it's strong and light, and it's used in a lot of supercars.
What's the radius of that pipeline? Inside radius.
We had measured it, and we measured about 63 inches. Around there, but we did not have a caliper.
How did you zero your gauge?
7-0.
Good. So there's a zero button on
Mm-hmm. Exactly. But I mean, as far as calibration on that gauge, you measure the height of the H or the height of the arc.
So
how did you zero?
So inside, I don't know if you guys see, there's this little lip here.
Mm-hmm.
So as you pull it back, it doesn't really matter where. I mean, it'll come back to a certain, but it will not come back to zero. But once you push it in and you zero it, this lip right here touches against this acrylic. That is exactly in the plane of this. And that's
did you subtract the thickness of that acrylic from your zero?
We're using R0 as this material here.
As the base material,
not
the aluminum?
Not the top of the acrylic. It's the bottom of the acrylic, which is flush with the top of this aluminum. And then from there, we subtracted the length of this to get our distance X and plug it into our formulas.
So what is the radius of the
right?
Also, we did not have a
5.25 with our current.
Plus minus 6 inches.
Plus or minus.
But the other thing is, we have this initial base distance here that we have to then add on extensions. In order to measure that, we used another dial indicator, which only measures change in distance. So we just struggled a little over there before we came over. But maybe with the caliper, we might be able to get a different read. So we'll definitely do it again. Hopefully, we don't get that far off.
Outstanding concept. I love it. I absolutely did. Just a little bit of fine tuning. I think you're definitely on something we're going to put in use.
I have
You're
to
going to
say-
save the hours of time.
I have to say, I mean, this is a topic that I actually brought up yesterday, I mean, with Daniel. And one of the things is that, and they have a very valid point, I mean, the whole group. Making that zero, okay, it is way more important because these things, they have an incredible tendency to get out of calibration. So getting that zero where you can physically push something, you get it where it hits, that is way more important. So we actually know one mechanical reference where that is the start of everything. The restriction is that it has to pull back, and therefore it gives you a negative number. So now the only thing that we have to do is that we'll have to make an adjustment as to the way that we will read the gauge, because the other option would be that we'll have to pull it back until we cannot pull back anymore, where there's nothing mechanically to stop it, and we have the risk to actually pull it out. So it was much better to actually have the that little lever on this little lever right here actually hits the gauge itself. So that's why, you can come up right here, and right here is loose. So when you come right here, I don't know if I can pull it, I won't do anything with it, but I'm sure that Bobby will have it, I think we'll go and take it out, that's stronger than me.
Who's been looking at games for 4 years?
Correct. This actually gives you, if you guys can hear this, that's black. And now, doesn't matter, you're pushing right here, and there's like a little stub in there actually is the one touching the inside. And I said, okay, I got it. I mean, that's why we have to push in with this particular device. We just need to learn how to read it backwards, that's the thing. Instead of going 30 some millimeters going that way, we need to read minus 30 some millimeters going back. So what allows it that whenever this number is not zero, we have actually zero number to actually do. Okay.
We actually had a different way of mounting it. So this is all a flat single pane across here. Put it down on the table, zero it on a flat surface, whether it's gauge block or something on a flat surface, and then.
And that will be coming next year. Tune in next year when we have another second step of the
And also, that fourth quarter projects are up.
And also, we have done another pipe chart, as they have one that Bobby reads in order to figure out how much he needs to measure. We're making one of our own, whereas the radius and the tolerance of 1/16 of an inch on the radius, which is a different tolerance in turn for the tolerance here. So as that changes, we have a column for a radius, a column for a distance x, and then a column for the display value. So Bobby can go up one or down one and see if he's in between that range of numbers, therefore he has a very good life. That's how he's been able to get
Lunch will be served next door. If you want to have a chance to talk to the students, please take a look at their artifacts in the hallway. And I think how much time? We're giving out about 55 minutes.
So no questions from you.
I retire with the era. Well, that's what happens the rest of the year. Oh, you know what, I am so looks good.
Why didn't you? What a big parade. I was going to ask you. We're live. Very nice project. Very nice. Good presentation. So where's the
So 3 o'clock.
You want to stay around?
Well, 3 or out, just out. Because he never took the time to pay.
As usual, good stuff.
It's like 2 hours later. I know, really, I'm happy to put it down. You too.
Yeah.
You too.
I'm bragging. I'm gonna brag like.